Okay, looks like I see most of the attendees responding yes, so I think we are good to go. Thanks a lot, Amit, and Data Platform Geeks team for giving me the opportunity to present in this webinar. So, today's topic I have is adaptive query processing and automatic tuning, one of the key features that are that's available in SQL Server 2017. So, typically I do this session as a session. So, I have the habit of asking a few questions, but let me see how I can adapt myself to this webinar style. Okay. So, but still, I would just quickly like to know how many of you have actually seen query plans at your work or use query plans? Can I have a yes or no in the chat window, please? Okay, few no's as well. Okay, okay, we have seen query plans. Okay, fine. Anyways, that's just to this session is deals with query plans, and so it would be nice if you could if you have some background on query optimizer and query plans. If not, that's still all right. I will still be able to take you along in this session. As the admin mentioned, I'm Nagaraj Venkatesan. I'm a data platform MVP from Singapore. I have been working on SQL Server for over a decade now, and uh, and I am a regular speaker at data platform events in Asia Pacific region. Do reach out to me. I have shared my contacts over here. Okay, so let's get started. So, what is this adaptive query processing and automatic unit? Before we get into that, so just a little bit of background about query optimizer and query plans. Typically, when a query is submitted, SQL Server generates the execution plan, right? So, what is this execution plan for folks who haven't seen or who do not know about it? In very, very simple terms, it is just a list of operations SQL Server has to do to run the query. List of actions it needs to perform to get the result. Something like an action plan. All along, this, there is a small notification. Okay. Okay, I noticed that there are some people who answer on the chat. I will, for the questions part, I will actually inform the admin to stop somewhere and take up the question somewhere in the team. Meanwhile, you can listen along and keep your questions ready. I will probably give one or two places where I will stop and I will take up the questions as well. Okay. So all along, you have this execution plan with the list of steps that needs to be performed. SQL Server generates it once the query is actually submitted. And typically, what happens is when the same query is repeated or when the same query is executed one more time, the plan typically gets reused. So this has been the method, or this is the way SQL Server has been operating for many many years. But in 2017, even though the same principles still apply, there is a slightly different different approach to it. The approach is it adds some more capabilities to the optimizer. One of them is to adapting to the runtime conditions, meaning when the query is submitted, SQL Server goes and looks at the estimates and comes up with the estimated query plan and passes it for the executor. Subsequent times, all along, it gets reused. But 2017 query optimizer is much more intelligent. It can take into account certain runtime behaviors and make some adjustments to the query plan. Not just that, but it also takes into account what happened at the previous execution. It takes some feedback and makes some adjustments to the query plan. So by certain degree, it is definitely a lot more intelligent optimizer in terms of creating the query plan and executing it. So in this session, what we are going to see is how it is going to behave intelligently, what are the scenarios it can automatically tune and provide you much better performance. So first thing, what happens, we spoke about the query of, we just briefly touched upon the query optimizer process. So what happens behind the scene once a query is submitted? For example, you have a query called select star from table where some column equal to some value. You have order by column 2, let's say. When you have such a query, what are the things that goes behind the scene? First thing, the query is parsed, the syntax is checked, and then whether the objects are there, it is verified. Once that's done, the query optimizer comes up with something called the logical tree. What is the logical tree? For the query I said, select star from table where column equal to some value, order by another column. In such a query, logical tree would be first read the table, filter the rows, first sort the results, and then project the columns. Basically, in very simple terms, the list of operations or actions at a high level that needs to be performed. Once it has the logical tree, it, it checks statistics. What are these things called statistics? Statistics are an internal data structure within SQL Server which can give information about the way in which the values are distributed in a column. Meaning, for the same query I just eh, said, select star from table where column equal to 50. It can say statistics actually say how many rows how many rows are equal to 50, or it can give information about how many rows in that table on that column between 50 and 100. These kind of information is provided by statistics. So what's when after getting the logical tree, it checks the stats to see each operation, how many rows is it going to return? How many rows will the filter return? How many rows my join is going to return? By knowing that, what it can do is it can it can actually find out how, how costly each operation is going to be. Depending upon the cost, it can enumerate the list of plans. After it enumerates the list of plans, it comes up with the cheapest plan, picks the cheapest possible plan and provides it to the SQL engine for execution. So statistics play a very important role in determining which operation to pick. For example, whether it needs to take an index C or an index scan, or whether it needs to use a nested loop join or a hash join. These are operators within execution plan. All these things are determined or are decided based on the statistics, right? Once the final plan is decided, every time the same query comes, it gets reused. So it looks just perfect, right? All along, this has been working very well for SQL Server. So what's the problem with it? It has some minor problems or issues. What are the existing issues? Is from time to time, it can have an incorrect plan choice, meaning the optimizer, after finding the cheapest plan, it gives to the database engine. In some scenarios, it may not be the most suitable plan choice, resulting in poor performance. Most of us, I hope most of you would have faced this kind of situation at your workplace where the query optimizer query plan is not so appropriate and you have a performance problem. Just a moment, just give me a moment, please. Are you all able to see my screen? Is there any disturbance? There is some noise in the background. I'm using a mic. I don't see any disturbance. Is it? Do you still see a disturbance right now? Okay, it's
Yeah, Nagaraj,
better. Right?
much better, Nagaraj. Yeah, carry on. If you, yeah, just a little bit of background noise was there, but it's good. It's good now.
Okay, okay. Sorry about it. Let me continue. Some people are unable to see the screen, but I suppose if others are able to see. Okay, okay. Sorry about the background noise thing. I hope it's much better now. So let me move on with with the with the session. So as I said, there are some cases where you can have a incorrect plan choice. What are the typical reasons for it? So the reasons can be inaccurate stats. Most of you or plan cache reuse. First, let's talk about the inaccurate stats part. Most of you would have noticed that that uh, that stats are not updated in real time, right? Typically, you have the setting called called asynchronous statistic update. I noticed some chat. Let me just check if there is any comments about the way the session is going on. Okay, I strongly suggest if you have any questions, kindly post it over there on the chat window. If not, I'm always concerned if people are not able to hear or something. Okay, so the reasons can be inaccurate stats or plan cache reuse. So let me about both the scenarios. Inaccurate stats can typically, as you may know, that statistics are not updated in real time. Meaning, typically, when you have asynchronous statistic update turned on with a standard practice, what happens is there is a threshold of changes that are needed for the statistic to be updated. Prior to SQL Server 2017, 2016, and earlier, it used to be 20% changes need to happen on the table for the statistics to be updated. 2017 onwards, there was a dynamic threshold that was in place. Though this particular dynamic threshold has been available as a trace flag since SQL Server 2008, 2017 onwards, it has been made the automatic setting. So, in layman terms, let's say if we go with the 20% formula, if you have a million row table, you should have at least 200,000 changes for SQL Server to automatically go and update the statistic. So more often than not you will be running with not so updated statistic. So what can happen? In the previous slide I explained how statistics are important to get the right plan. So it can result in a improper operator choice, eventually resulting in a bad performance. Right. Second scenario is plan cache reuse, or as somebody pointed out, parameter sniffing issue. This scenario is also pretty common. Okay, to explain that about that, let's say you have a first time you submit a query for a or you submit a call to your stored procedure USB underscore procedure one with a value something equal to with the parameter value equal to 60. At the first call, this particular stored procedure, for this value, it returns, let's say, on a million row table, it fetches about 80% of the table, 800,000 rows. It starts to fetch. So for that, obviously, when you are fetching most portion of the table, well, it is it is suitable to use a table scan or a cluster index scan, right? So first time when the query is submitted with this particular value, it compiles with the value that has been passed, and it comes up with the with table scan to be the appropriate operator. Subsequent time, let's say all other calls to the same stored procedure with a different input parameter value start fetching lesser amount of rows, let's say 5 rows or 10 rows on that particular table. Then what happens is all these calls start getting table scan operator, right? So because query plan gets reused. At one hand, reusing query plan is an effective way of working because compilation is an expensive process, causing a heavy workload on the database. So SQL Server tries to reuse the query plans as much as possible. But on the other hand, when your data is fairly skewed, or in some scenarios, when you're depending upon what kind of first call you have, you can end up with a totally inappropriate plan choice, causing in poor performance. So, what is the current approach we have as of now? We can just prior to 2017 wait for SQL Server to fix. It can be after restart, or after the statistics automatically get updated, or after your maintenance jobs actually update the stat. Or in some scenarios, you can use things like forcing a uh, forcing forcing a query plan by using a hint. Or if you are on SQL Server 2016, you can use something like a query store, with which you can actually force a plan choice. So all these demand certain amount of action from your end, or from the database administrator, or from the development team inside. SQL 2017's optimizer attempts to address some of these scenarios automatically. The adaptive query processing and automatic tuning features actually help you address some of these scenarios by themselves and make some changes. In this session, in the next 40 odd minutes, I will be going through what are those scenarios with a few demos, and how SQL Server can actually help to address these. Before that, let me just take a quick look at the chat window just to see if anybody has anything that you want me to address. There is no screen change. Yes, the session will be recorded, and it will be updated. Are you all able to see the screen change? Okay. Okay. Fine. I'm just clicking through the chat window just to ensure that I don't see anything. I don't miss out on anything. Okay. Fine. Let me move on. So one thing is, just because I say that the optimizer is improved, and so it doesn't mean all the parameter sniffing problem will be automatically addressed. Adaptive query processing helps you to solve certain problems at certain scenarios. There are 3 scenarios as of date which will be addressed by adaptive query processing: memory grant feedback, adaptive joins, and interleaved execution, which I'll be covering in this session. The roadmap is from the product team, SQL Server's product team, is this would further be extended. Like most of the features of Microsoft of late, they introduce a particular feature and it gets further and further extended as we go along. Okay, before getting into adaptive joins, first I would like to touch upon certain fundamentals. Here, some very simple fundamentals on 3 types of join operators that are available within SQL Server. So, for most of you who already know, please bear with me for this slide. But for the folks who do not know, we have three types of join operators. When I mean join operators, these are internal algorithms or execution plan operators which SQL Server uses to process the joins. For example, when you have a query called select star from table, where from table join inner join column A equal to column B, something on that line, and then you have these kind of operators which actually help you to process the query. So, or to be precise, to process the join. So what are these operators? Nested loop join, hash map join, and merge join. So each join is picked by SQL Server's optimizer depending upon on scenarios, certain scenarios. When both the tables that are participating in the join, table A inner join, table B on column A equal to column B. So when both the table A and table B are fairly small, then nested loop join, you find nested loop join to be typically picked. Just about few hundred rows or few thousand rows, then typically nested loop join is picked. Or then one of the table the one of the table is small and the other table is big, but it has an index on the joining column. Then also nested loop join can be picked. In that case, the outer table is the smaller table and the inner table is the bigger table, but it has an index. Meaning nested loop join, you can imagine it just like if you're a programmer, typically you have these loops, right? For I equal to something, for j followed by begin, and then you open another loop called for j equal to something, and then once you have a match, you return the result. So in a typical sense, this nested loop join is something very similar to it. Other operator you have is hash match join. Hash match is picked when two tables are fairly big, right? And they do not have an index. When both the tables, in that case, it uses a hash algorithm, uses something called hash algorithms and hash buckets to make the join happen. Excuse me. Sorry. Third option is merge join, which is picked when both the tables are fairly large and both the joining columns are indexed. So if you notice the size of the table, which typically gets determined by the statistics play in operator. Enough of slides. So let me show some demos. To understand how adaptive join works, I prefer to explain it with a demo. Everyone able to see the change of the screen? Are we able to see the query window? I'm not able to watch the SQL Server window, but I also see some yes. Okay. Okay, moving on. So I have this query inner join on the stock item table is having an inner join against order table. Let me open up the query plan as well. So you notice something called adaptive join over here. So what it is let me just zoom this thing. Okay. So what basically it does, it comes up with something called adaptive threshold rows. What it implies is when it tells that when your outer table of the joining query, when it contains more than certain number of rows, when it returns more than adaptive threshold number of rows, go to hash match join. If it is less than certain the adaptive threshold rows, then use nested loop join. In a very simple layman terms, let's say you take a, let me give you an example. You take a taxi from airport to your hotel in a city like Bangalore or any of those cities. If you check the Google Maps, it will tell you something like take this highway, go 5 kilometers, take a right, go further straight, and so on. Right? In some sense, execution plan is something similar. It tells you the list of operations that SQL Server needs to perform to reach the destination. Over here, if you notice, let's say after you start the journey, you have something like an accident of sorts, or there is a small traffic jam in one of the highways. What do? You typically take a diversion. Let's say Google Maps says you go on this highway, you wait for 10 minutes. If you are still stuck on the highway, take a different route. This adaptive threshold join is in some sense like that. What it says is, if the number of rows coming from the outer table is more than that stipulated threshold, then switch to hash match join. If not, go for the nested loop join. The threshold is determined by at the compile time by looking at the query and looking at the cost, but the actual plan choice of whether to use a nested loop join or hash match join happens at the runtime. On the on the on the window I'm showing, on the query optimizer's properties I'm showing, if you notice, adaptive threshold rows is 68.5. So if the rows are more than 68, then go for hash match. It is estimating rows. I'm switching the compatibility level to older one so that you can see how what happens. So it has picked up a hash match. Estimated number of rows was about 95 rows, and it has picked up a hash match operator. Now let me switch the compatibility model to the new one and rerun the same thing. It returned about 36 rows. It has used adaptive join, which is good. What it has done, if you notice, observe the most important part of the third line from the top, actual join type. What it tells is actual join type is nested loop. Observe the fifth row, it says estimated join type. Estimated join type was hash match, but it actually ended up using nested loop. That was because look at the adaptive threshold rows, which is 48.6, and how many rows did it estimated 95 rows, so it thought 95 greater than 48, so hash match is the right way to go at compile time. But because it got only 36 rows, it decided to take nested loop join. It dynamically switched the join operation in runtime to nested loop, which is cool, isn't it? So this way, actually, even though the plan gets reused, but still the join operator gets switched dynamically depending upon the rows that are returned. Okay, eligibility. Does all queries qualify for adaptive joins? No. Only it can make a choice only between nested loop and hash join operators. As of now, only batch mode operators are supported, meaning there are two types of mode of execution within SQL Server's automator. One is called row mode, which is the most common one. Batch mode helps to process the rows in batches. That is typically applied when you have operators like column store operators, not restricted to it, but typically. So as of now, it is supported only for all the adaptive join properties are supported only for batch mode operations. But I hear from the product team that it would be extended further to row mode operations as well. The adaptive join threshold, which is the secret sauce, it is defined in compile time, but it is determined by the cost, just like you do for any other query in the previous days. Only the threshold is determined in the compile time, but the plan choice varies at each execution. What are the key properties in the query plan? I already showcased that. So let me move on to the next part. Okay. So next part we have is memory grant feedback. Imagine the scenario. You submit your query is submitted. It goes and checks the stats, and then typically after checking the stats, it comes up. It tells the query optimizer or the database engine that I need certain amount of memory to run this particular query. This is the estimated amount of memory I need to run this query. Once it comes up with the estimate, when the query gets started, the memory is granted. But as we saw, if the statistics are not updated or if the plan gets reused, then the estimates can be off and you can have inaccurate request for memory. What happens when you ask for a lot? What happens is the query has to, first it's a waste of memory. That memory could have been used for some other query, but it gets granted and it ends up not using it. Typical scenario is the estimate was for 1,000,000 row, but the query in runtime actually consumed only 100 rows. Then it asks for 100 MB or 500 MB of memory, but ends up using only 5 MB of memory. Or other way around as well. There are scenarios where it underestimates, meaning it thinks that it needs only 10 MB of memory, and in runtime it notices there is lots of rows are being returned, and it ends up using the 10 TB for the excess memory that was needed. Both the scenarios are not so desirable because it can cause performance problems, right? So excessive grant also means that the query has to wait for excessive amount of time till those memory pages are granted to the query, right? It has to wait for something that it's not going to use at all, which is not desirable again. So what happens? How does adaptive query processing actually help to address this problem? Let's see now. Okay, so what I'm going to do is I'm going to put the compatibility model to older estimation, and I'm going to run this. If you notice here, it has, notice here, it has asked for about 68 MB of memory. This is in KB, memory grant 68688. It's in KB, so roughly about 68 MB of memory. If I click on properties, And if I expand over here, observe this max used memory, maximum amount of memory used by the query in runtime. That's only about 9.7 MB, right? It asked for about 68 MB and it ended up using just 9 MB. It's the same thing at the second execution as well. Now, let me run the same query against by switching the compatibility model to SQL 2017 so that we see how adaptive query processing can help to fix this problem. The first one says 68 MB. First time it was granted 68 MB, just like the older one, no difference over there. And if I right click and say properties, it has used 9.7 MB. Okay. 68 MB granted, 9.7 even in the new one. But second time when I run, what happens? Or second or third time? If you notice here, when I run it second time, it has made the adjustment as 10.7 MB, meaning it has changed the grant. Max used was about 9.6 MB, and actually how much it got granted was 10.7. So, and even on the third time, it has granted 10.7 MB. It has made the adjustment for the oversize. So what happens behind the scene is what happens behind the scene is SQL Server actually gives the feedback. The query optimizer, after the execution gets completed, it feedbacks to the plan cache saying that, okay, this particular query, you granted this much amount of memory, but it ended up using only this much. So subsequently, when the next time, when the same query is run and the same plan is accessed, a correction is made. It makes the adjustment to correct the mistake that happened last time. How it works is you overestimate at least if the usage was 50% less than what it was actually granted. Then it is categorized as overestimate and adjustment is done. Or underestimation, if there is a memory spill to 10 dB, then it is categorized as an underestimate and the correction is actually carried out. So this way, actually SQL Server's optimizer does the correction for for over and underestimation of memory grants in query optimizers. This can all these you need not do anything. It automatically optimizer does the correction. Let me just quickly check if there are any questions. Somebody asked, so changing the compatibility is changing the SQL Server version? Yes, it is. Meaning when you use a different compatibility, are these applicable for the past DB as well? That's a good question. Yes, it is. Yes, it is indeed applicable for Azure Past Database as well. For 68, there was another question as okay. A batch mode of okay. There are quite a few questions that are coming. Just let me take it one by one. There was a first question was as charts are being updated by No, stats aren't being updated. That's what I was actually showcasing. Meaning stats aren't updated. Threshold is there at 68 rows, but in runtime, even though stats aren't updated, we are able to make the switch because you have something called the threshold which can actually decide. Never, no, you won't get this because the focus of this session is not about merge join. Adaptive query processing can make the choice only between hash match and nested loop. Can you give examples of batch mode operators? Typically, queries using column store indexes. You can probably search the list of things that fall under batch mode operation. What happens if parameter value changes? Will it take the first memory grant? That's a very good question. Even if the parameter value changes, the feedback is continuous, meaning the plan you have is at the compile time, but the estimate is still whatever is the first value that it decided. But after the query completes the execution, it goes and gives the feedback and it makes the correction. So if the value changes, the last memory that it was granted takes it. Meaning, in our example case, we saw 10.7 MB as the latest one. Let's say if I change the parameter and if I run, next query gets 10.7 MB. And if that is not appropriate for the subsequent execution, it makes the switch. Can adaptive query processing of can it help to solve eliminate weights like CX packet weight? Okay, potentially possible if the CX packet weight is typically due to, for the scenario I can think of is let's say it estimated like 100,000 rows and decided to it estimated a much bigger cost and decided to split it across many processes. But because you are having a nested loop join, potentially the processing can be much faster and eventually reducing the CX packet rate. Maybe it is pretty much possible for it to reduce many of those kind of issues as well. But directly it doesn't address your CX packet rate. It just ensures that you get a lot more better plan choice, which can perhaps prevent those kind of issues as well. Yeah. Okay, let me move on. I think I have hardly about 10 to 15 minutes left. So let me quickly go through the rest of the session. If there are questions which I can't take up, I'm more than happy to respond via email as well. My contacts are there on the slide. You are free to shoot me a mail too. Okay. Okay, I understand there are quite a few questions, which means everybody is there. Most of you are connected to this sessions. One of the challenges in doing a webinar is you do not know how the audience is actually reacting to a session. So looking at the questions, I am happy that most of you are getting what I'm talking about. Definitely the slides will be shared. No worries about it. I cannot see the screen. That's very unfortunate. Sorry about it. Okay, move on quickly. Next scenario we have is something called interleaved execution. Interleaved execution is another scenario which is applicable to queries using multi-statement table value functions. When you have functions, there are typically you can classify functions as scalar functions or table valued functions which return a bunch of rows. Scalar function just return a single value like get date or any other typical date function and so on. Within table valued functions, there are two types. One is called the inline function, which actually expands. It behaves like a view on the query. When you use the inline function, the definition actually expands and inline. And another one called multi-statement table valued function, which actually which actually for each row being processed, the multi-statement table valued function gets executed. Multi-statement table valued function allows you to write multiple statements within the function, and it returns a bunch of rows as the result. So this is the way a multi-statement table valued function looks like. You have multiple lines within the function, and it returns a table as a result set. So what we are going to see is in SQL Server 26, prior to SQL Server 2016, when you use multi-statement table value function, what happens is it used to come up with a blind estimate of one row. SQL Server 2016, they changed that blind estimate to 100 rows. But either ways, when you have a multi-statement, the number of rows returned out of the multi-statement table value function is a blind estimate. 2017, what it actually does, the adaptive join processing, what it does is at compile time, it executes the multi-statement function alone, materializes the results, or in other words, it actually executes that section, stores the results, and uses the row count to come up with the design for other parts of the query. Meaning, in this query, if you notice here, I have the function over here, table fact.order joining to MBF, test MBF. So after the join, what happens is when this query is fired in 2017, actually this particular function, this section alone gets executed, the results are stored, gets the row count, and finds the operators for other portions of the query. Let me demonstrate this by running it against both automators. As usual, I'm going to switch the compatibility level to older one and showcase. If you notice here, table value function is a blind estimate of 100 rows. In reality, there was 136 rows. If I switch the optimizer and move to and run it against 2017, what happens is this 136 rows, meaning over here, it actually, you see that the estimate is exactly same as the actual value, simply because first it runs this test MVF section, stores the result, and then takes the row count and tries to figure out is it good to use hash match or it decides the other operators. So only with batch mode operators can benefit this particular feature, the queries with batch mode operation, as I stated earlier. Okay. And more importantly, for this to work, the value over here needs to be hard coded. If let's say you are passing the value from the order table, you are passing a column as the input. In that case, it won't be able to take advantage out of adaptive join, or it won't be able to execute upfront and come up with the estimate. It will still go for the blind guess. When you pass the value of a column over here, typically you won't say in inner join, you use something called cross apply operator. So in that case, it doesn't work, which I have stated on the slide deck as well. Okay, now we are up to the final section of this session. So, and we are also close to our actual closing time. So this is probably a lot more interesting part of this session, this particular session. It's the automatic tuning part. So in automatic tuning, there are two parts to it. One is automatic plan correction, which is available in SQL Server 2017. Automatic index tuning, which is available only in the PaaS version or Azure SQL database. Only it is available only in the cloud, automatic index cleaning. This section will be about automatic plan correction, which I will showcase in SQL Server 2017, which is, in my opinion, is an excellent feature addition to SQL Server. Most of you, I'm sure, would have heard of something called regression, right? Or regression testing or query regressions. What is regression in the first place? Let's say we have a system, we have an application where we introduce a few indexes or we introduce some changes to enhance the performance of the database. And we notice that the performance has improved, but there are certain queries which have started performing badly after the change, which have regressed. These queries were performing all right till certain period. All of a sudden, we notice a sudden performance drop. How we also have this not just at a particular thing, or even in cases like after a restart, till last week the query was running fine. After on this Monday, the query is running very, very badly. We have had this scenario so many times. SQL 2017 can actually help you to address this directly. Let me demonstrate how it does. So what I typically mean by regression is I have the same query text. There is a sudden change in query plan and it results in a bad performance. For example, imagine this to be your query. The yellow bar is plan 1, blue is plan 2, green is plan 3. All these three have more or less the same performance. Suddenly I have plan 4 which is giving me an awfully poor performance, right? Those kind of scenarios, typically you call them regressed plan or regression. So query regression. How SQL Server actually addresses is SQL 2017 can automatically detect regressed query plans and automatically force to the last known good query plan. It is just a database level setting. There is no code change that is required. All you need to do is alter database, DB name, set automatic queuing equal to force last good plan on. Once you do that, automatically the plan gets this regression queries are automatically handled. Let me demonstrate this. This feature needs query store to be running. So I'm just turning on query store, and then I'm also turning on the setting force last good plan on. Okay, I have turned it on. Now what we are going to do is we are going to create one query with two different plans. One plan is suitable for a particular parameter value. Other plan is suitable for a different parameter value. And then what we are going to do is make the optimizer use an inappropriate plan choice, thereby causing a poor performance, and see how it actually goes. So what I'm going to do is I'm going to clear the cache. Let me just do this demo and then we can close. It's a little past 6:30. Okay, in my time, which is past 4 o'clock yours. I'm clearing the cache and have turned on the phone. It has picked up what it has done. I'm passing the value 2. It has counted about 2.9 million rows. For counting so many rows, the appropriate operator is hash match operator. It has thought that hash match is best suited, so it has used it. Let me run this query a few times. Let it run. So most important point is I'm passing the value 2. It has picked up hash match as that is suitable. Now let me load a different plan for the same query.
I'm clearing the cache so that it doesn't reuse the plan. Now, I'm passing the value, I'm passing a different value, 1. So what happens over here is it has just read one row, and the appropriate operator for reading just one row is stream aggregate operator in this case. Now, on the cache, now we have the plan that is suitable for reading just one row. Now I'm going to pass the other value 2 so that it is going to use the inappropriate plan choice. It is going to use the stream aggregation. But in reality, what is suitable is hash match. So let's see what happens, or is it able to automatically detect it and force the plan choice. I'm running it a few times. Let me just read on this. Let me just stimulate it again. For some reason, it is not behaving the way I expected it to behave. Meanwhile, I think for the query plan to actually, it uses query plan behind the scenes. So for it to actually understand and force, it takes a few seconds. So let me just give it a wait and let me just on this page. Okay. If you notice over here, it is using stream aggregate, even though hash match is suitable. Now let's see what happens over here. Okay, if you notice, after 13 to 14 executions, it has decided that stream aggregate is not suitable for this particular plan, and it automatically switched to hash match. The reason first time it didn't work was because this feature uses query store, so there needs to be a little bit of gap behind the scene for it to detect and force the plan. Let me also just quickly show what it has done. We can see via the DB tuning recommendations, DMB. If you notice here, it actually tells us that it did force a plan, and it did because the CPU time actually changed from 13 milliseconds to 553 milliseconds. So this way, actually, it is able to switch the query plan and automatically. It has internally, it has certain threshold that needs to be at least 15 executions for it to 15 executions of core performance for it to make the change, and the performance at least needs to be 3 times forward. For it to force, at least it should have a 3 times gain for it to force the plan choice. These are internal formula which is not even publicly available. I actually checked with the product team to understand what is the formula that actually decides when it is categorized as regression. So, but the roadmap from the product team is that they will be making these configurable, meaning you can even in upcoming versions, you will be having the option to even fix like X number of executions and X amount of CPU time and so on. Then automatically force it. You will be having the power to configure it as well. with this, I'm down to the end of my session. Let me actually look into the chat window to see if there is any further comments. Okay, so with this, I'm down to the end of the session. I ran by a few minutes more. So after this, I will pass it over to our admin. If you have any further questions, please let me know. If you have any comments also, please let me know. Yeah, I'm more than happy to answer them. Hope the session was useful to all of you. Thanks a lot. Somebody is asking, remove parameter.
Yes, so thank you very much, Nagaraj, for this wonderful session. Nagaraj, if you could please mute.
Just
Thank you, Nagaraj, for this wonderful session. And friends, hope you enjoyed today's webinar. And as I mentioned, there are many more webinars that are lined up. For those of you who joined us a little late, just wanted to quickly recap on the Data Platform Summit that is coming up in the month of August in Bangalore. 3 days of conference and 2 days of pre-con. And the best part is about 11 speakers are already announced. Some great folks are coming down from US, Europe, Singapore, New Zealand, and 15 other countries. So please check out dps10.com. This is one of the best learning events you would ever attend. More than 100 sessions are going to be delivered by 50 speakers. If you want someone from our team to get back to you, just drop an email to contact@dps10.com. And every year, this conference, this Data Platform Summit, is going to be hosted in dps10.com. Microsoft product team members are flying down. Our favorite Sunil Agarwal and SQL Cat team, Tiger team, they're all flying down to deliver sessions here. And apart from gratitude to the DPG members and eDominant teams for hosting it, special thanks to Microsoft for supporting our community initiatives. All of you are members of DPG already, so continue being a member and leverage all our free learning resources out there. And I know many of you have questions. Because we have come close to our webinar end time, please post your questions in these groups. Your membership is already approved on Facebook and LinkedIn. I also request all of you to please give feedback. Your feedback is utmost critical for us. It really helps and motivates speakers like Nagaraj and many others to continue contributing to our community initiatives. So do have your feedback out there. Quick word from our sponsors, SQLMaestros.com. Please go and check all the learning resources that are there out on SQL Maestros. Masterclasses, hackathons, the SQL Server health check. And again, if you have any questions, drop an mail to classes@SQLMaestros.com and someone from the team will revert back to you. I wanted to bring your attention to Hands-On-Labs. This is a great learning platform. Let's consider this. Today, Nagaraj showed so many different demos. If you want to practice this yourself with step-by-step instructions, this is the place to go to. We have more than 120 hands-on labs today, and each lab is divided into multiple exercises, and each lab is pretty long, takes about an hour to complete, and we are trying to cover the length and breadth of Microsoft Data Platform. You'll find topics on SQL Server, Azure SQL Database, Azure Data Factory, R, Python, machine learning, and almost anything under Microsoft Data Stack. With this, we really thank you for your time. More webinars are coming up. We had a few glitches today, as I understand the audio and the screen sharing, but of course we will fix all of that going forward. So continue learning from us. Tomorrow, the next webinar is by Sandeep Pani on Introduction to R in SQL Server, followed by Chris Testa on Introduction to Artificial Intelligence platform with Microsoft. Many more webinars coming up in the month of March. You can find all of them at DataPlatformGeeks.com. With this, we will end today's webinar because we have overshot the time. I request you to please post your question in Facebook group and LinkedIn group, and I will request Nagaraj to please answer those questions there. That will be helpful. So thank you very much, and all of you have a great day.